Today we're going to continue to look at linear equations. And what we want to focus on is the different ways that these linear relationships can be expressed. So we have equations, but those equations can also be turned into tables or turned into graphs. They can also be represented in word problems. So we want to be able to look at all the different forms of a linear relationship and be able to interpret it. We want to be able to change from one form to another. All right, so our goal is to be able to today take tables and change them into equations. And we're going to do this by including the variables and the rate of change in the equation. So this is a pretty big clue. We have two variables in this problem. We've got quarts represented by Q, so that's our first variable. And we've got liters represented by L, that's our second variable. So we're using these two variables, and we're using the rate of change. And the rate of change is something we're going to have to find in this table. Notice over here, they've already shown us that it's increasing by 0.95 every time, where over here, we're increasing by 1 every time. All right, so the rate of change over here in this table would be 0.95 over 1, or simply 0.95. So now we have the three things we need. Remember, they asked us to use the variables and the rate of change. So we have two variables and a rate of change. Now, how are these connected? Well, if we look at the problem that they're asking us in example 1 on page 268, it says, write an equation to find the number of liters in any number of quarts. All right, so we want to know liters. So liters, I'm trying to find out liters, and how do I find that using quarts? Well, if we go by the rate that we've already discovered, 0.95, I know that if I take any of the quarts and I multiply by 0.95, I'll get the liters. So how do I take those words and put them in to an equation? Once again, the number of quarts multiplied by 0.95 is going to give us the liters. So liters equals the 0.95 times the number of quarts. So what we've been able to do is come up with our equation. Now, if we look down at example 2, then they ask us, well, now how can I use that equation if I know the number of quarts? So they're telling me that I'm going to have 8 quarts. Well, once I have the equation, I've done the hard part. And all I have to do at this point is take what Q is and substitute it into the equation. So if I rewrite this equation now, I have L equals 0.95 times 8. And when we do 0.95 times 8, we get 7.6. So L equals 7.6. So let's recap what we were able to do. We were able to take this table, identify the two variables, Q for quarts and L for liters. We were able to find the rate of change, otherwise known as the slope, or the change in y over change in x. We found out that that was 0.95, and we realized if I take the number of quarts and multiply by 0.95, I will get the number of liters. So I was able to put that into the equation, L equals 0.95 Q. And now that I have an equation, I can use any number of quarts to identify how many liters I have. Let's try one more example to make sure we're understanding this concept. In this example, I have a similar idea. I've got measurements. Here we have distance, and we've got metric measurements of kilometers, and then the one that we're more accustomed to in the United States, which is miles. Okay? I once again want to come up with an equation that represents the relationship between kilometer and miles. And be careful about what the question is asking. It says, I want an equation to find the number of miles. So I want to come up with miles. So if you already know kilometers, what will the miles be? So that leads me to believe that miles is going to be kind of like the answer to this equation. So what do I have to do to my kilometers to get miles? Well, notice the rate of change in these problems. We've got increasing by 0.62 each time, increasing by 1 each time. So my rate of change is 0.62 over 1, or simply 0.62. So I know if I take my kilometers and I multiply by 0.62, that will give me the number of miles. So how can I write that in an equation? So once again, miles is going to equal the rate 0.62 multiplied by the kilometers. Okay? So then how can I use this equation now? Well, let's say, for example, you decided to run a 5K over Thanksgiving. All right, a 5K. So all I would have to do now is do a substitution, 0.62, and instead of K, I'm going to put in the 5 kilometers, and I'm going to get 3.1. So if I ran a 5K over Thanksgiving, then I ran 3.1 miles. So remember, take the two variables that they're giving you in the problem, okay, and see how they're related with the rate of change. I would like you to go ahead and try the got it, A and B, at the bottom of page 268.